All right, let's begin. Now, let's recap. Chapter 18, listening? Chapter 18, what were you meant to have learnt in Chapter 18? There were a couple of things, and it all ties in together for these application questions. So this is exercise 18E, okay? Some of the points that you would have learnt. How to find the equation of a tangent and a normal line. So that's first exercise. You needed to find the equation, which is y equals mx plus c. Okay, so using derivatives, how do you find m? That's the whole point. Okay, so finding equations of tangent and normal. Need to know how to do that on your CAS. The second part, I then taught you the power of stationary points. Okay, so we spent about 2, if not 3 sessions on this. So stationary points, we looked at how to find stationary points, so f dash of x equal to 0. And then you also have what is the types of stationary points. So you had types, and we went through how do you prove or justify it. Okay, so that's more important for the algebraic components when you're doing the exam or SAC, if they ask you to justify it. Most of the year 11 content, they don't ask you to justify. Year 12, they do. Okay, so at this point, you've got stationary points. Those two itself should lead into now our last part, the difference between a local max or a min, so stationary points, versus absolute max and absolute min. Okay, now in order to do this last component here, you should know this part. That's from stationary points and how to find the types of stationary points. What is an absolute max or absolute min? You're going to refer back to all your skills in methods so far, from quadratics to cubics to exponential logs. You're relying on that to answer this question, domain range. Okay, so that's why it's an application problem. You're putting it all together. Okay, so how do we do it? Let's do an example together, and I'm going to show you the skills that you're embedding and what exercise 18E is really about. So as long as you've got these 3 key skills, that's chapter 18. Chapter 17 was all about derivative skills. Okay, so I taught you the 6 rules, chain rule, product rule. You learned those, that's chapter 17. Chapter 18 is to apply, solve, sketch. Okay, so you can see that would be part of exam 2, and probably the second half of your SAC will be related to chapter 18. Okay, chapter 17 is based on your algebraic skills, your theoretical knowledge. Okay, so here we go. Let's have a look at this example here. There's an application type question. Your goal here is to model this situation, and most times in application questions, even if you can't model it, they always give it to you. Okay, they have to give it to you, otherwise you just lose like 10 marks or so. So even if you didn't know how to do the first one, don't give up. Use that first part to then answer B, C, and D. So even if you didn't know how to do A, you can lose 2 marks there, but you can use this equation to then answer B, C, and D, providing that you understand tangents, normal, stationary points. Okay, so you shouldn't have any reason as to why you're losing 10 marks for a question just because you don't know the first step. Okay, but the first step is you need a model. So here we go. Let's read what the question is asking or telling us. They say, from a square piece of metal, okay, you've got a square piece of metal of side length 2 meters, 4 squares are removed. So you need a picture in this diagram that you originally had a square. This was the original square. Whoops. This was the original square. And 4 of these squares from each corner has been removed. So they're already telling you that the original length was 2. That's 2 meters. And that's 2 meters from here to here. Okay? Then they say that, okay, the metal is then folded along the dashed line. So you can see the dashed lines. If you fold it, it forms an open box. So if you can try to picture this, if I fold this up, each and every one of these sides up, you should have a shape that kind of looks like a very flat rectangular prism or box. Okay, so if you can kind of picture that, I'm just going to do that line down like that. That would be your box there. So you're picturing it. This is X. Okay, because they said height of the dimension is x. Now they're saying show that the volume of this box. So prove in part 1, prove that the volume is equal to 4x cubed minus 8x squared plus 4x. So you're going all the way back to your junior mathematics. How do you find the volume of a rectangular prism? Okay. How do you normally find the volume of a rectangular prism? What do you have to do? What's the formula to find out the volume of a rectangular prism? V is equal to? Yeah, very good. I'm teaching my year 8s that right now. Okay, so very common that we know how to find the volume. So write that down. Start off there. If you don't know where to start, say, all right, they're asking find volume of box. Draw the box and say, all right, well, I know it's length times width times height based on this box. In the diagram, I only have x, which is the height. I'm missing this length and this length here. Okay, so looking at the diagram, when you flip this up, clearly this is x. That's your height. When you flip it up, that becomes your third dimension. That's your height. So the question is, this must then be length and that must be width. How do I find that distance? See, I'm trying to figure out, how do I know how long it is from here to here? That's what I'm looking for, from here to here, because I already know this is x and that's x when you fold it up. How do I find that?
Did the question say it was a square or a box?
They said it's an open box.
From a square piece of metal.
Correct.
Which means technically all the side lengths should be the same if it's a square to have it as a point.
That is correct. So if I remove 4 squares, okay, so let's just say that these 4 squares, I'm going to remove x amount. That's x as well. So that means this is x, and that's x there.
So would the side lengths be 2 minus 2x?
Very good. That's literally it. Because we knew the full length was 2, and I'm removing x, and I'm removing x. So it's 2 x's. 2 take away 2x should be the side length here. And it'll be the same theory for the bottom length as well. So that means this is 2 minus 2x, and this is also 2 minus 2x. So answering the question now, length and width I have. I now know this is 2 minus 2x, and I know this is 2 minus 2x. So length times width times height, I should have length 2 minus 2x multiplied to 2 minus 2x times the height, x. This is the model, but you need to prove that it will turn out to be this. So I can expand the brackets. I can expand that and I can combine it right now. That can be 2 minus 2x all squared times x, or you can expand it as you would, and that would have been 4 minus 4x plus 4x squared, and that's all multiplied to x. So you can see this now becomes 4x minus 4x squared plus 4x cubed. But that goes back to quadratics, term 1, mathematics, expansion. So I expanded this using perfect squares expansion. Okay? Is it different? Or it means I've done something wrong. Oh, thank you. You're right. It was 2 times negative 2 is negative 4 times 2 is negative 8x. Negative 8x. And then this is plus. Is that correct now? Oh. Oh, but then you're timesing the x as well. There we go.
So, there's a tip I can give you. For the 2 minus 2x squared, you can just flip the insides to 2x minus 2. Since it's squared, then it wouldn't matter at all. And it would just look a lot better because there's less negative.
Oh, so taking out the negative for this one.
No, the one below, the square.
This one?
Yeah, so you can make that into 2x minus 2 squared.
Yeah, so you've taken out the negative outside, like that, and that becomes 2x minus 2 squared x. And then without the negatives, it becomes easier to see like that. Is that what you're saying? Yeah. Very true, very true. That does help. And then that's the proving part. But that's what I'm saying. If you couldn't do this step here, they already gave you the answer. Okay, so even if you couldn't have moved forward, you already have the volume question. So you would have lost 2 marks for the setup, sometimes 1 mark for the setup. If you couldn't do A, that was the only part. But then B, C, D, you can use that formula to move forward. So here we go. Let's look at B. B says, find the value of X that gives the box a maximum volume. Okay, so we're going to paste it in here. Here we go. Oh, where'd it go? Oh, I see why. Here we go, B. Find the value of X that gives the box its maximum volume and show that the volume is a maximum for this value. Okay? First step is to understand, what are they asking when they say max volume? Absolute max. So think about it. You're given a formula. You got volume is equal to 4x cubed minus 8x squared plus 4x. Visualize this. Try to visualize. If you can't remember, this is a CAS type problem. You can use your CAS to picture it. So here we go. I'm going to go control, add graph, and we're going to do 4 times x cubed minus 8 times x squared plus 4x. Right? This is what my graph looks like. Okay, so I'm going to zoom in. I'm going to go menu. Use all your CAS skills from here. So we're going to go to menu. If I can tap it, doesn't seem to tap. Menu 4, zoom box. And I'm going to go over here and I'm just going to select one corner to the next corner. There you go. That's my graph. Okay, so I'm going to screenshot this so that you can visualize it. This is what your graph looks like. And what they're asking, okay, I'm just going to paste it up here. I'm going to bring it down. Here we go. So I've got my graph. That's what 4x cubed minus 8x squared plus 4x is. And they're asking you to find the value that gives the maximum volume. Let's have a look at this graph. If this is a volume equation, so this is volume and this is x, which is the amount of length of the square that you're removing, okay? Clearly, it doesn't make sense to have negative volume. That doesn't exist. So negative volume, if you ask you to sketch it, you should be sketching this bottom half, okay? The next part doesn't make sense that your volume is infinite, okay? So it must mean that you had a box that can't be 0, okay? So it can't be 0, but it has to be a box of certain value, like a capacity. Then it goes up to a certain value that is maximum before it comes back down, and again, it can't be 0, okay? Whereas all this wouldn't make sense. So there's a practical domain here. The domain for this, though it is modeling it, there is a section that you do not include. Yes?
Can we go to 0 to 1, right?
I haven't looked at it, but you're probably correct. If we...
It's the length of the box.
Yep, 0 and 1. So from here, you can solve for that x-intercept. When does volume become 0? And you can see that it's when x equals 1 and x equals 0. So it would be that this is from 0 to 1. Okay, but what you can see here is the question's asking you to find the maximum volume. Now you can do that on a CAS to find this point. Now when you get this point, which value are you using? Which one is the maximum volume? Because you're going to get an x and a y coordinate. Which one is maximum volume?
Y.
Why? Because the y-axis is your volume. It's your y value, right? So I often see students put the x value. It tells me that they're not understanding what the equation represents. It represents volume. So then when they say, show that the volume is maximum for this value, they want you to find the x value. That's what they're referring to. What is this x value? And show that the maximum, which is the y value, is that. Okay? Now, what's another way to find this max value without a CAS? Very good, because it's a stationary point. Okay, that's a local max. So we know that we can find it if it was an exam 1 or SAC 1 component, if I asked you to find the maximum and you didn't have a CAS, then you would know that delta V delta X is the derivative, and that would give you 12x squared minus 16x plus 4. We need to find when this has a stationary point, and based on what we see, there should be 2, 1 and 2. Okay, but we're probably going to choose the one with the smaller x value, which we know is less than 1. Okay, so stat point occurs when delta V delta X equals 0. So now you're trying to solve for 0 is equal to 12x squared minus 16x plus 4. And that goes back to, remember, at the start of the year, I said that it's important that you know how to factorize and solve, because that was the beginning. And then from here, you're tying it all together, knowing cubic graphs, understanding domain, understanding range, knowing which areas will be the ones that you're sort of looking at. And all we're adding on right now is calculus. And all the part of calculus was to find stationary point. That's it. But you're tying everything together in this topic. Yeah, so here you can solve it and simply take out a common factor. I'd say 4 is a common factor, so you got 3x squared minus 4x plus 1. See if you can factorize this. This is 3x. See if I can do it. That's 1, 1. So maybe, yeah, that works. So therefore, you get x is equal to a third or x equals 1. Okay, which makes sense because in our diagram before, 1 is a turning point and the other one clearly has to be less than 1, which is a third. So now I know that this value occurs when x is a third, but I just don't know what the y value is. How do I find the y value? Very good, not the derivative. But if I sub it into the derivative, what am I going to get? Which is 0. Okay, so that's what I mean. When students sub it in, I question, I'm like, so what should the answer be? And they get 0, and they're like, answer 0. Well, but does that make sense? We're dealing with volume. If it's volume, how do you have a box of 0 volume? But they write 0, happily. Yeah, I know, that's what I'm saying. But so we think about it logically. What are you doing? Don't just sub it in. Think about what you're actually doing is what we're trying to train you to do, to be more critical. Okay, so this question here, you're right. V, sub it back into the original volume equation. So V was equal to 4x squared, x cubed minus 8x squared plus 4x. And that's how you would find. But remember, this is a CAS problem. I was just asking, how would you do it if you didn't have a CAS? Because the key word there was maximum volume. Okay? And so in this case, we know we can find the max volume. So going back to our CAS, here we go. Let's show you how to do it on a CAS. Define V of x, if you want to, is equal to 4x cubed minus 8 times x squared plus 4 times x. I would then say find the derivative. Now, how do you find the derivative? I would also define again. I call it g of x, for example, is equal to the derivative. Shift minus is derivative. Because I've defined the function, I can write v of x. So what if I wrote here? Here I said this is what the function is. Here I'm saying g of x will be the derivative of that. So that now I don't have to type the derivative over and over. I can just type g of x, and that's the derivative function. Okay? So in my CAS, I would simply press enter. I've got my derivative now. What am I trying to solve for? I'm trying to solve for when the derivative was equal 0. So that means g of x, which is my derivative, I want that to equal to 0, comma, solve for x. Apparently, we should get a third and 1. There we go. We've got a third and 1. Okay, but I know that it's a third that I need. How do I find the y value for it? That's the volume. So here we go. V of 1/3, 16 on 27. So unless the question asks for decimal points, give it decimals. If they don't ask, you give it an exact value. And that with the units. Okay, so in our case, the units should have been in, was it meters or centimeters? Meters. Okay, so you would have wrote 16 over 27 cubic meters. And that would be the max volume. Can you see what I'm doing there? So that was meant to be a quick question with a CAS, but how would you have done it by hand? This is how you would have done it. And that's the difference between exam 1 and exam 2. Yeah, it's about applying using your algebra, whether you know your factorizations, null factor law, applying stationary points. That's what it is. Okay? And let's have a look. Next one, sketch the graph. As long as you're not sketching these sections here, so your graph should be more like this. I would do an open circle, comes up, comes down, open circle, 1, 0, label the max point. That was 1/3 and 16 over 27. Vx. Okay, so that's sketching the graph. And then what was the last question of that? They said find the values of x for which the volume is 0.5. So they're saying in D, if the volume is 0.5, what should x be? We've got the equation. So we go back to our CAS. If the volume, so solving for if the volume is equal to 0.5 equals to volume. So that's my volume equation. Solve for x. There we go. That's the exact value. If you want it in decimals, control enter. Which one of those makes sense? Okay, so think about the graph. Why do I have 0.19 and then 0.5 and then 1.3? Because the graph originally looks like this. You're asking it, when will volume be 0.5? Right? So if this was the 0.5 mark, of course there's going to be 1, 2, 3 different values. But which one of those fit in the domain? That's what you're answering. Okay, so that's what I mean by understanding what the function represents. How do you sketch it? That's what makes this exercise interesting or trickier. But what I've done there, what was the hardest part? Really is probably this component, the algebra component, the theoretical component. Okay, but in terms of doing it, you just need a formula. So there you need a model. You can lose the first 2 marks if you couldn't get it, but you can definitely do B, C, and D once you have this. You've got a CAS. Sketch it, analyze it. That's where the skills, you're tying everything you've learned from the start of the year to now to do these types of questions. Okay, so there's many of those examples there. You've got this one, a different canvas. You've got a simpler one. So this one just gets you to think about absolute max and absolute minimum. For those who don't know what an absolute max is and absolute minimum, remember when you get a cubic, sometimes this is your cube, right? But just because you've got a turning point, that doesn't mean that's the highest value. Okay, so when they say absolute maximum, it can be the turning point. But in this particular situation, this is the highest point. We call this the absolute max. So the only way to know is after you find your turning point, you have to compare your y values, which one has the largest y value, and absolute minimum is which one has the lowest y value. It's a very typical year 12 question. They can give you a graph that could be like this. And so you might find a stationary point here, stationary point here, stationary point here. Where is your highest value? Which one's your lowest value? It may be, it might be the local minimum, but your highest value may not be the local max. You have to sketch it to see. And remember, this often happens in exam 1. You don't get a CAS. You can't sketch it. So you can only rely on stationary points, y values, plug and play to kind of visualize what it could look like. And that's where the skill comes in. Okay? And that's the difference. So if you're doing these exercises, you find that some questions, when you have the CAS, it's nice to picture it. You have to be able to use your CAS to see that. So this is a big exercise. The questions go up to, I think, 16 questions, but they're all 16 worded problems. So start working on them to see, but that's the expectation for your SAC. Okay, so your SAC in the second component, expect something like this. You're going to get some sort of shape, some sort of scenario. You're finding a maximum or a minimum using derivatives either by hand or by CAS. Okay, but that's exercise 18E, and that's chapter 18. Sometimes they'll ask you for a tangent, sometimes they'll ask you for normal, but you're just tying all that together to analyze a function. Cool? Not the easiest.